Before we talk about interval notation, we need to refresh our minds of these four symbols. The first one is read as is less than. This symbol is read as is greater than. This symbol right here is read as is less than or equal to. The fourth symbol here is read as is greater than or equal to. Now there are two ways we can use these symbols. We can use them to form mathematical statements. For example, I can use this symbol right here to say 5 is less than 7. And this is a mathematical statement. Now remember, what we mean by mathematical statement is it's some sort of assertion. You're claiming something. And a mathematical statement can only be true or false. It cannot be both. And there's no maybe. Okay? So 5 is less than 7. This is a mathematical statement, and we find that this is a true statement. I can also make a false statement using the same symbol. If I say 1 is less than 0, you know this is a false statement because you know that the real numbers are ordered. When I look at where 0 and where 1 is, 0 is to the left of 1, and the numbers on the left are less than the numbers on the right. Let me also make a statement using is greater than or equal to sign. For example, I can say 6 is greater than or equal to 6. Is this statement true or false? We learn it is true because when we use this symbol right here, if either the number is greater than or equal to, if it satisfies one or the other, then it's true. In this case, even though 6 is not greater than 6, it is equal to 6. Since it satisfies the second part, the whole statement is true. And the same way, I can also make a false statement using this greater than or equal to symbol. For example, 10 is greater than or equal to 20. Is 10 greater than 20? No. Is 10 equal to 20? No. Since either of those is not satisfied, this is a false statement. Now moving on, the second way we can use inequality symbols is to talk about chunks of numbers. Chunks of numbers on the number line. Now, what do I mean by chunk of numbers? Okay, before I go on, this is also called an interval. Let's look at our real number line here. Now, on this number line are infinitely many numbers. Let me mark some. 5 and so on, it continues to the right. I have -1, -2, -3, -4, and so on. It continues to the left. So here I have infinitely many numbers. But depending on the problem, am I interested in all these numbers all the time? No. So I would like to talk of, for example, a chunk of numbers. Numbers from 2 to 5 maybe. Right? Maybe my problem only requires all the numbers from 2 to 5. Or I may be interested in all the numbers that fall between -4 and 2. Maybe I'm interested in all the numbers between 6 and 7. Who knows? But either way, it all depends on the problem situation. So how do I represent these chunks of numbers in mathematics? Let x be a real number. Now let's say if I want to talk of the numbers from 2 to 5, including the numbers 2 and 5, this is how I show it on the graph. I make a dark circle on 2 and extend the line up to 5 and make a dark circle on a filled in circle on 5. This means I'm talking about all the real numbers less than or equal to 5 and greater than or equal to 2. Again, this is how I read it. All real numbers greater than or equal to 2 and less than or equal to 5. It helps to read from the variable outward. When the variable is in between the two inequality signs like this here, it means we're talking about the numbers in between the two other numbers, and we'll know if we're including these endpoints if the circles are darkened or not, or if we have less than or greater than or equal to symbols, these right here. Let's look at a few more examples the same way. Now if I want to talk of all the numbers greater than -2 up to 3, not including the number 2, including everything in the middle, and including the up to number 3 and including the number 3. So I write x, we're talking about all real numbers which are greater than -2. Notice I don't write the equal sign because there's an open circle here. And less than or equal to 3. Because of this less than or equal to sign, I darken the circle over here. Now what if I want to talk about all the numbers greater than -4? On the number line, I put a open circle on -4 because I don't mean -4, I only mean the numbers greater than it. So I make a arrow to the right because that's the side that the numbers are greater on. And I write x, it's all real numbers greater than -4. Since I don't have that equal to symbol, it's an open circle and it's not darkened. Now let's say I want to talk of all the numbers less than or equal to 2. Well, all the numbers less than 2 are on the left, so I make a arrow that way. And since it's or equal to 2, I darken the circle on 2. And these numbers I'm talking about are all real numbers x less than or equal to 2. Now before we move on, I want to show you the easy way of writing all these intervals here. And let's go back to our first one. Okay, here we were talking about all the numbers in between 2 and 5 and including 2 and 5. Now using the simple interval notation, I can write this as a close parenthesis 2, 5. We use this sort of parenthesis when we say that 2 or 5 are included. In this case, they are included. Remember this darkened circle. Okay, so whenever you see this sort of parenthesis and two numbers in the middle separated by a comma, we're talking about a chunk of numbers or an interval from 2 to 5, including the 2 and 5 when we have this sort of parenthesis. Let's look at the second one. Now here we're talking about all the real numbers greater than -2 and less than or equal to 3. And in interval notation we would write -2, 3 and a close parenthesis on the side of 3 because the number 3 is included and the number 2 is not. We use this parenthesis. Let's look at the next one. Here the chunk of real numbers we're talking about is all the numbers greater than -4. So I make a open parenthesis, write the -4, and then it's from -4, not including -4, all the way to the right, going on forever. So here to express that idea we need a new symbol, and we use this one. It's called infinity, and it just means that you're going to the positive direction forever, like this arrow tells you. You're starting at -4, you're not including the -4, right, this open parenthesis, and you're going forever to the right. You're including all the numbers to the right. Let's look at the next one. Here we're talking about all the real numbers less than or equal to 2. So I write with a new symbol everything on the left. This is negative infinity, up to 2, and I use a closed parenthesis because this right here is darkened. We are including the 2. Okay, negative infinity is again just telling you about this idea that you're including everything on the left. You go to left forever up to the number 2. Okay, it's not a number itself. Now let's summarize all this. When I'm talking about numbers in between two other numbers and not including the numbers themselves, I write as, well, I'm talking about all the real numbers greater than some a and less than b, meaning this could be 1, this could be 5. All the numbers greater than 1 but less than 5, not including the 1 and 5. Of course, I write open parenthesis here, comma, open parenthesis here, because these numbers are not included. The same way, if the numbers are included, I have a dark circle. Then in interval notation, I write it like this: a closed parenthesis around the endpoints. And I'm talking about all the numbers from a to b. Here, a and b could be any real numbers. For example, it could be from -4 to 16. So here I would have -4 to 16, and we're including the -4 and 16. And the same way for the other one. Go through it one by one. And I mainly want to highlight this one right here, which says, okay, look at the number line. You're starting at b, not including the b, but you're including everything below it. So here we're talking about x, all real numbers less than b. If b is 6, I'm talking about x less than 6, which I write as, well, from 6, not including 6, and going down forever to negative infinity, to lower numbers. And the last one, negative infinity to positive infinity. Now this, again, these two are not numbers themselves. We're talking about the idea that you're going all the way to the left, all the way to the right. Well, then you're talking about the whole number line, and that is the set of real numbers. So go through this again. Remember that a and b just represent some real numbers. So pick two real numbers and see what each of these means. Open circle, you use this sort of parenthesis. Closed circle, you use this sort of parenthesis. Infinity, meaning all the numbers to the right. Negative infinity here, meaning all the numbers to the left. So remember that and try a few examples of your own.